Let's start today. And the idea today is we had last session where we understood some of the overall architecture or components in Kubernetes. So today it's going to be about how do we set it up on local, and then we will understand a couple of options how we can install Kubernetes on AWS cluster as well. So that's going to be the target for today. Gonna be more on hands-on rather than just slides. So welcome again, I'm Praveen Salitra, engineering lead here at Innit. If I describe Innit, pretty top of the stack in terms of data visualization and applications, streaming data engineering apps, and of course all powered by cloud native DevOps. And mostly, well, I should say everything that we run so far is on containers. That includes Kafka to databases to UI apps to backend APIs to even Jenkins or Git or Jira or Confluence or whatever it is, Dockerize everything, right? So last session we had an overview of Kubernetes, the recording and everything is all available. So you can go and head over to this particular URL. You can see the recording. Today we're gonna be talking about how to set up Kubernetes locally as well as on AWS. So some of the questions that we will try to answer by the next 60 minutes or so are this. What components are needed to be installed when setting up Kubernetes, whether it's local or on AWS? How to set up Kubernetes on the local machine, on AWS, but most importantly, how to set it up in a fashion so that it's highly available. You may have heard this keyword, highly available or HA, more often with the DevOps, with the clustered setup. When you have your infrastructure, you want to make sure it never goes down, right? It should be able to scale automatically. If a node goes down or an EC2 machine goes down, it should be automatically coming back up, but without disrupting your production workload. That's the whole point. So we'll understand how to make it HA ready. In the majority of the demo today, we'll be using Kops, which is also called Kubernetes Operations, one of the CLI tool from Kubernetes ecosystem itself to install Kubernetes cluster on AWS. But there is also a managed service which came almost 6 months ago or 8 months ago. It's called Elastic Container Service for Kubernetes, in short, EKS. It's from AWS. We'll talk about some of those options as well and how they are compared to ones using Kops. And then at the end, we will talk about some of the important things to keep in mind while working with Kops and Kubernetes. So this was the last diagram that we left with last time. We try to understand what are the different components, right? So if you see all the blue ones, yep, that's what I'm talking about. So Kube API Server, Kube Scheduler, CCM or KCM or etcd, these are on the master side. Of course, you have a CLI on the outside called kubectl, Kubectl, however you want to pronounce it. And then on each node of your workers, you want to have kube proxy, proxying of your network within pods itself. And then you have kubelet, whose responsibility is to make sure the containers are live, up and running, right? If they go down, bring them up. That's the whole point of these two daemons that you have running per worker node in your Kubernetes cluster. So it seems simple from the way that, if somehow we can find out Docker images of this, we should be able to run these containers. If we can find out an AWS AMI, Amazon Machine Image, we should be able to run up master and worker node individually. Yeah, right. It makes sense. The whole problem is just the configuration. It's a little complex, and we'll try to see it today, and then we'll understand, are there any tools or managed services which can simplify this setup? So that's the whole target for today. So same diagram, but without the workload here. These are the components we are trying to install, configure, run, make them talk to each other. So as far as setup is concerned, I would say that's a big learning curve. If you want to understand how it is set up properly or how these components are talking to each other. If you don't care about what's happening under the hood in your Kubernetes cluster, yeah, there are all these managed services provided by almost all of the cloud providers. You don't have to worry about it. Just from UI, you can go and set it up. But that's not the whole point, in my opinion. So you require a pretty good understanding of networking, configuration management, and infrastructure if you want to understand deep details about how you set up Kubernetes. We'll try to go through today, and in the end, we'll use some tools to simplify those, how complex it is. So the first one I want to describe is, let's say we want to go on this idea of creating this cluster from scratch. Just understand, we will not do it, but just understand how complex it can be, right? Or overloading it can be. So you can see a lot of things you would need. If I go start, of course, you need a kubectl CLI on your machine because you will be talking to a cluster after that. If, let's say, you have decided the cloud provider, whether it's GCE or whether it's AWS or Azure or IBM or something, maybe on-prem as well, right? So you have to figure out if you need the CCM, the Cloud Controller Manager, or not, right? If you are running on-prem, the CCM coming with Kubernetes binary may not be available to you or may not be relevant to you. You may need to figure out some other pieces there. Then you need to figure out, okay, what are the configurations of my worker nodes? How many CPUs do I need? How much memory do I need on this cluster, and all this kind of stuff, right? Some of the minimum requirements for the nodes and the masters that you have in order to run Kubernetes cluster. Most important thing is to understand networking part of it. Now, remember, here you have a lot of overlaying architecture. If you start from very top in the networking, you have the VPC. Then you have subnets, which can be public and private, depending on your requirements on the security side. Then you have nodes, right? You have master nodes, you have worker nodes. Then within the nodes, you run this Docker containers, or Kubernetes will abstract them using pods, and then Kubernetes will provide service discovery as well. So you are talking about a lot of networking configuration in this case. Pods will have their own IPs, nodes will have their own IPs. You will have kubeproxy doing proxying or load balancing across your pods, but then you have services. Then you may also involve a cloud load balancer like Elastic Load Balancer on AWS. So a lot of stuff going on there as well. So you have to decide some of those pieces about what is the CIDR range of my nodes or my VPC or my subnets. What's the NACL, what security groups, what's the CIDR range of my pods as well, because they also need IP. So those kind of things. Other thing is, since you ultimately need connection or networking between pods and not EC2 machines, right, you need to provide or understand at least one network plugin out of all of this. Kubernetes supports something called container network interface. It's a little different than the original network interfaces that you have heard about when they are talking about virtual machines, but this is a different thing. This is talking relative to the containers. So there is a concept, has been there for at least last couple of years, container network interface. So that's one other important thing. Then there are implementations of it, and you have a lot more there. Now, if you are dealing with cloud providers, specifically to GCE or AWS, they can influence networking in a different way. In AWS, you have VPCs, subnets, routing tables, NACLs, security groups, a lot of the stuff that you have on the AWS side, and same thing is applicable everywhere else as well. Same thing, you have to decide what CIDRs you would be using for nodes versus load balancers versus pods versus services. Then, of course, what is the name of your cluster, right? Let's say you are playing with multiple clusters, multiple Kubernetes cluster. Maybe you have 3 different clients and you want to set up them on their own Kubernetes cluster. And maybe you have a dev environment Kubernetes cluster, but then you have a staging cluster and prod cluster as well. It can be any combination here. So you want to identify this cluster with a unique name. That's the name of the cluster. I think the simplest piece to decide what should be the name of the cluster. Then you have to find out, okay, fine, all configuration, at least details are ready. Let's find out where are the binaries, or in short, Docker images for etcd, one of the container runtime, either you are using Rocket or Docker. And then, of course, kubelet, kubeproxy, API server, CCM, KCM, kubescheduler, a lot of those pieces that we have seen before. They are all available on GCR, Google Container Registry. Of course, it's an open source project. You can go ahead and then download it depending on the version from here. You have all those binaries in source code as well. You can build it locally. A lot of these options are available to you. Then you want to make sure your API server that will be exposed in a limited or open fashion to the world, you want to make it secure, right? So that means you have to generate some certificates. So a lot of certifications you have to figure out, since your nodes will also be talking to the API server, if you remember this piece. So you have to make sure your nodes are also authenticating to API server. Just because the node is in the same VPC as the master, it shouldn't be allowed to talk to Kubernetes master by default, right? So there has to be authentication as well between these two. Kubelet has to have a certificate. And then for the first time when you install the cluster, you need credentials to log into from your kubectl as well, right? Same stuff. You need a credentials. Maybe it's a alphanumeric string for the easier stuff. In the next session, we'll talk about how to harden this security with using AWS IAM. That's for the next session. So these are all the stuff that you need, and then you need to keep on installing them with proper options. So you need to install Docker, then you need to install Kubectl with a lot of configuration about where are the certificates, where is the cluster IP and all that, what's the domain where you're running, where is the Docker running. Kubeproxy will also need some sort of configuration there. Then same thing goes for the networking as well. Maybe you have to modify touch IP tables every time you're deploying a new service, new pod, new workload, whatever it is. So a lot of stuff is there that you have to manage if you are dealing with installing or setting up Kubernetes from scratch. And that's where I would say Docker Swarm is easiest option. No learning curve because it's already installed in your Docker engine with your Docker engine. Kubernetes, on the other hand, it's very, very customizable and it's very complex environment, but the learning curve is of course very heavy here as well. And that's the whole part of the discussion today. We want to understand how we can simplify it. So quick recap, you need to figure out what cloud provider you are or on-prem. On-prem is a little complicated because Kubernetes by default will not provide you all those binaries. You have to figure out all those pieces from third-party vendors, all open source again. Node configuration, you have to figure out, okay, if we are going to be having a highly available cluster, how many AZs, I'm talking about AWS in this case, what masters in what AZs and how many nodes per AZs and what's the auto scaling policies and all those. We have to figure out, okay, what networking we're going to be using. We have to note down what CIDRs for the VPC, for the pods and everything we'll be using, name of the cluster, the DNS entry in it. We have to make sure we buy a domain name, right, for that cluster, or at least configure the name servers for a domain or a subdomain. Binaries for all the Kubernetes components. Many TLS certificates we will need for the HTTPS of API server, for the interaction between node and the master, because the whole communication within the Kubernetes cluster is on TLS, and then the bootstrap configuration for each of the component, right? So at the end you realize, you know what, it's a lot of work even to understand and try it out. Are there solutions which can do all of this for us within a couple of commands or maybe from UI? That's where Kubernetes has a list of many solutions, and it has created a page called picking the right solution. There are solutions for local machines, the hosted solutions where you can go from the UI and then install Kubernetes on any other cloud provider. These are provided by many companies with a price, free, depends on their pricing model. You have some turnkey cloud solutions as well. Within a couple of commands, you will be able to just create a Kubernetes cluster on any cloud provider. We will use one of them called Kops today. You have some on-premise options. You have some custom solutions if you want to go from scratch and all that. So for the local, you have Minikube, one of the very famous before Docker integrated Kubernetes inbuilt, but this was the famous one before Docker integrated it. So we tried it a year ago. It works very well. Just install a single VM on your Mac, your Windows, your Linux, and then runs Kubernetes in a single node fashion. So that's the whole point here. Hosted solution, a lot of them, including AWS EKS, your Azure, your Googles of the world, or IBM Clouds, or maybe OpenShift as well, which is the Red Hat flavor Kubernetes that you have. OpenShift, behind the scene, if you think, it's just Docker and Kubernetes and some services built by Red Hat on top of it, giving you as PaaS, platform as a service. That's OpenShift. Oracle also has Container Engine. This is the first time I'm reading it. Turnkey cloud solutions, again, command line mostly, which will allow you to install a Kubernetes cluster on all these providers. One that we'll use today for AWS is called Kubernetes Operations, Kops. There are others as well from CoreOS. CoreOS has a huge influence on the cloud native world. Now I think Red Hat acquired earlier this year, but that's one of the company that you will hear more often. But going forward, I think we will call it Red Hat. On-prem, if you are interested there are on-prem solution as well, which you can look into. And then if you want to start from scratch, you have Kubespray as well. There is Kubernetes for Ubuntu and a lot of other stuff. And again, by this list, you are again puzzled, thinking, you know what, that's not helping. The previous one was throwing me off the charts using all the configuration and tools and everything I need. Now it has given me a lot more options to try it out, right? So what should I use? I just want to deploy my microservices on Kubernetes cluster. That's it. If that's your target, I would suggest going directly with whatever cloud you are using, just go find out a managed service from the cloud provider. If it's AWS, just go and use EKS. If it's Google Cloud, just go and use Google Kubernetes Engine. Same thing goes for IBM Cloud or what else? Azure. Yeah, that's one. That's the fourth one. So if your target is, you know what, I just want to deploy my stateless microservices, or maybe a couple of volume-based services as well, where I need to store data and persist it, yeah, just go and use this. You don't need KOps, or you don't need any complex setup for all this. But then if you are in a situation or in a team or a company where you would go and want to understand everything in detail, you want to harden the security from every angle, you want to have control over each piece of customization, and then you have requirements like, you know what, nope, I have to run a clustered service within Kubernetes or on top of Kubernetes. For example, I want to run Spark cluster on top of Kubernetes. Some of these services may not handle your requirements. Some of these managed solutions may not handle your requirements. Or maybe you want to run your entire Kafka cluster, which is internally itself a clustered service. You want to run it on top of another orchestration framework like Kubernetes, right? So it's complexity inception there. So all these kind of things comes into picture. And that's where you realize, you know what, maybe this managed services are not going to help me. I have to go and deploy and take control of every bits and pieces of the configuration, and that's what we will understand today. But again, if your workload is very simple, you just want to run containers without worrying about where are my masters, how large or how should I scale my masters up and down, whether those are highly available or not, how should I even set up all these things. Yeah, if your workload is very simple, again, go ahead, use your managed services right there. Cool. Now, and that's what I'm talking about, our approach, Inet's approach in that case. So locally, we just for testing stuff, not these days, but maybe a year ago, we used Minikube. Today, I'm going to showcase Docker engine support, which is already inbuilt in Kubernetes, just for the local one, to test it out, maybe some configuration of your applications, not the Kubernetes, because it's still a single node cluster, just that you will be able to run some container there or a pod there and then see, oh, it's okay. On AWS, because we are right now primarily on AWS, our approach is to use KOps. And one of the good things about KOps is it can output or export into Terraform format as well. So we may use the same configuration in the future when we, let's say, want to support Azure as well for some of the clients. So nothing changes. It's the same configuration, and Terraform will take care of deploying it to Azure or Google Cloud or whatever comes in the future that Terraform supports. Another option, of course, as I said, is EKS on AWS. Pretty easy to set it up. Towards the end, we'll do it. For authentication, when you deploy it via KOps barebone, it creates a hard-coded Kubernetes cert and certificate for you, and the CSR as well, certifying authority for you. But then in order to harden the security of this cluster, we actually moved on to use AWS IAM. We have integrated it with another tool called Authenticator or IAM Authenticator, which is what actually EKS also uses under the hood. AWS is managing this particular project. They took it from Heptio, so when they wanted to create EKS. Accessing the cluster, ultimately you just need kubectl, which is available as an installable on your Mac, Windows, Linux, whatever you call it, and it's there. It's available on all the package managers you can think of, depending on your operating system. So one of the, of course, a requirement that you will have, a prerequisite, is to have Kubernetes CLI or kubectl or Kubectl to be installed on your machine. Think of it like a CLI, right? You use Docker run, Docker images, Docker container, everything. Kubectl is a way to make your applications deploy, or you want to manage your applications on Kubernetes from your command line, right? That's kubectl. It's a CLI. API server is what it is talking to. So it has a configuration that it stores locally on your home directory inside .kube/config. Once our cluster is set up, we'll understand what that configuration is, but that's how it is. And since we use IAM Authenticator here, or integrating with AWS IAM, we can actually make this public, this configuration public as well. And unless someone has access to IAM, yeah, they can't do anything with the kube config. That's one advantage that we got with this kind of setup. So let's talk about KOps. Kubernetes operations, they claim it's, and of course we have seen it, we have been using it for almost 10 months now. Production grade Kubernetes installation, upgrades, management. One important thing here is KOps is only going to be talking about cluster. It's not talking about your apps. So the responsibility of KOps is only to give you and manage and upgrade your Kubernetes cluster. That means masters, the components running in masters, right? Nodes, worker nodes, and those kubelets and kubeproxy components. What you run in that cluster, what applications that you run, your Nginx applications, maybe your Node.js, your Spring Boot, your databases, anything, that's not the responsibility of KOps. If you want to run your application, you have to use kubectl, right? Because at that time you are talking to the API server. KOps is just giving you the playground after creating the cluster, and that's what it is helping you. So just want to clarify, KOps is not kubectl, right? They are different things. It's an opinionated provisioning system. It's a fully automated installation. All the complexities that we have gone through, this guy will take care of it all in single command. It will use DNS to identify cluster. So the naming of the cluster has to be, I prefer it should be with the name of the DNS that we want as well. I will describe when we do it. It's a self-healing cluster, meaning if a node goes down, it will come back up on AWS because it's setting it up using auto scaling groups of AWS automatically for you. It supports multiple operating systems, whether you are on Debian, Ubuntu, CentOS, RHEL, Amazon Linux, CoreOS, whatever you can prefer. You can plug your image AMI type. It has support for all of them. We use Debian for that. It can set up your cluster in a high availability fashion as well, meaning more than one master, meaning one master per AZ, and you can have multiple AZ within the same cluster. All that kind of support is available. You should be running more than one master, each within its own availability zone within your Kubernetes cluster for your production workload. Definitely, one of the benefits that I mentioned before, it can provision and generate Terraform manifest, Terraform templates, right? Down the line, if you want to move out of AWS or alongside AWS, you want to support other cloud providers as well, this is going to help you there. Terraform is going to help you there. And awesome community support, I would say. Actually, that's true for everything in the Kubernetes world. They have dedicated Slack channel, and then you can see whether it's EKS, whether it's KOps, whether it's Kubernetes, whatever. There are many channels that you can go and access a lot of good stuff on the entire ecosystem, not just KOps or Kubernetes. And of course, it's part of the Kubernetes project, GitHub itself. A pretty good amount of stars, a lot of commits and everything is going on. Very popular, right? Before EKS came into picture earlier this year from AWS, this was the de facto way of creating a Kubernetes cluster on AWS. Now it has a support for GCE as well in beta right now. Looks like VMware was in alpha, still in alpha. Definitely, it's not the silver bullet for all the cloud providers to set up your cluster, but at least for AWS and GCE, it's there. And then if you can export them as Terraform, yeah, you can go and deploy anywhere. Now, I think we'll come back to the cluster specification a little later. Let's go and talk about one of the very important things from the newer age DevOps practices that we like here at Innate, and we kind of propose as well to everyone, is this concept of immutable infrastructure. And that's very different from the legacy world, because now you have this cloud providers, right? You can remove the nodes and bring new nodes in anytime. There's no extra cost of it, of replacing a node. As long as you can support, you can make sure your production workloads are still running while you are doing the swapping of nodes. Maybe you want to change the size of the node, right? Maybe from M4 large, you want to go to M5X large, or a new generation has come in and you want to upgrade it. You want to do it, but you don't want to do in-place upgrades. You want to just get rid of this cluster, bring a brand new cluster within 15-30 minutes and done, right? Change the load balancer DNS and done with it. Same thing goes if you heard about blue-green deployments, almost with the same concept. You don't want to do in-place upgrades. That's a thing of the past now. So if that is the case, you want to make sure all the configuration that you ever do on your cluster, starting from launching a virtual machine to installing some libraries, some things in it, and configuring every piece of it, you want to make sure it's coded or it's part of your code. It should be committed to your repository, right? The concept of infrastructure as code. So that's the whole point. KOps let us adopt that principle of immutable infrastructure as well as infrastructure as code all the configuration that we ever need to create a Kubernetes cluster or our entire AWS cluster, we don't have to do it by SSHing into the machine. We just do it from command line here using these tools like Terraform and Kops, and we just commit that configuration to our GitHub repo. Next time we have to run it using some other commands, we can just apply that configuration somewhere else, change some values, maybe create a brand new cluster. So that's how helpful it is. Gone are the days when you would be going and SSHing into these nodes and then installing or doing apt-get install there on that machine and doing all this kind of stuff. The problem with that old approach is once that DevOps team member is gone, no one knows if it's not documented what happened, right? How it was set it up. I have seen this kind of story many times in many companies, including some of my past experience of the projects. Cool, a lot of talking. Let's go into the work. So the first thing is, how do we set Kubernetes in local machine? One of the options that I talked about before was Minikube, available just as a binary. You can just install it using Brew or on Linux or probably on Windows as well. It just runs a single VM virtual machine, I think using VirtualBox behind the scene, a single node cluster of Kubernetes, and then you have everything available. We are not going to be using that. Instead, I'm just going to enable Kubernetes in Docker engine itself. That's one of the best thing happened at the start of this year. So let's say enable Kubernetes. Don't worry about this piece. This is to, in Docker world, there is a Docker stack CLI as well. Think of it as Docker Compose for Docker Swarm. But then, of course, last year they figured out, you know what, this is not going to work out. Let's support Kubernetes as well. Again, don't worry about this. Just enable Kubernetes, apply. If you run it for the first time, it will take some time to download the binaries from Kubernetes to run a single node cluster and all of those pieces. But if once it's installed at least one time in your machine, then you don't have to worry about it. It will just boot it up, and then you can already see that in Kubernetes here you have an arrow, and then it has a context called Docker for desktop, because that's your local cluster, the name of the local cluster which is running on this machine. Yep. I am using Z Shell, which has a plugin to tell me what cluster I am talking to right now. Very helpful. Will give you some idea about what the shell is later down the line. Because if you are running multiple clusters, you want to know where you are fighting your commands against, right? Not like dev versus prod and all that. Still starting, let it start. And that's it. Running Kubernetes locally, that's the whole thing you need, nothing else. You are ready with your applications to deploy on local machines. Of course, there is no value other than maybe you are just trying out it for the first time, getting the feel of kubectl and different objects, but nothing more than that. Cool, so it is running. You can just do kubectl cluster info. It can tell me that, okay, the local API server is running on localhost 6, whatever that port. There is another service called kubedns is running on this particular URL. I'm using another tool here to change the configuration and change the namespaces for this particular cluster. Think of namespaces as logical separations that you can have within your cluster, right? You may just install one large cluster of 20 machines, 20 nodes in your AWS, and then logically separate it, saying, you know what, I want to have a dev environment in the same cluster, a staging environment, a prod environment, and they should be somewhat isolated. Mark my word, I said somewhat isolated. If that's okay with you, you can use the concept of namespaces. Again, logical isolation of your Kubernetes workload within the single cluster. You can do that. So these are different namespaces. Kubesystem is a namespace where all the Kubernetes related services are running. In this case, again, remember, this is a single node cluster. You have etcd, remember the database that Kubernetes uses? Yeah, that guy is running here. API server is running here. Kube controller manager is running here. Kube proxy is also running here, because remember, this is a single node. It is a master, it is a node as well. So both of those pieces are running. Kube scheduler is also running there. And then you have kubedns. Now kubedns is an interesting component in Kubernetes cluster. What it does actually, when a pod needs to talk to another pod, if an application needs to talk to another application, it can just use the names instead of worrying about, oh, where is that pod deployed? What is the IP of it? What is the port of it? kubedns, it's an internal DNS manager or system that Kubernetes run, and that can help you. Just looking at the name of the other application, this particular pod can talk to it, can send requests to it. So something like, let's say if you have one as WordPress and other pod is MySQL. WordPress pod can request to MySQL just saying MySQL colon or HTTP, not HTTP, TCP, MySQL and whatever that port is, right? 2306. So that's what kubedns does. So these are some of the components which are already running locally. Let me go back. In the default namespace, I don't have anything else. So let me quickly deploy a simple Nginx based image. It's just a simple website. So before you run to install AWS CLI, you have to have it if you are talking to AWS. kubectl is called Kubernetes CLI there, and then you need to have Kops as well to install cluster on AWS. But right now, at least you need this guy because that's what I'm using here, kubectl. So once you have these prerequisites, then let's play with installing a simple image that I have. It's an Nginx based image with a Docker well logo on it. I want to call it Nginx app. I want to create 2 replicas of it, and I want to expose the port number 80. If you are coming from the Docker world, think of it like Docker run, but it's just that it has 2 replicas, right? That's the only difference. Let's run this. So go there, paste it. Before, when I did, get me all the pods. If I do now, I should see 2 pods. Both of them are deployed separately, and these are 2 pods here because I said give me 2 replicas. Now you will be like, fine, these are 2 websites running, or 2 replicas of the same app running here. How do I access it outside? Is it available on localhost port 80? Let's try it out. Nothing. It's not available there, right? And the reason, which we'll understand down the line in more detail, is that these are not exposed to the host. The port 80 that we did before or saw before is only the container port within the pod itself. It's not exposed so that you can reach out from the host. For that, we need to create a service, or we need to expose this particular deployment out. There is a simple command. Down the line, you'll understand more concepts around services, different type of services. I'm just using a node port service which will open another port on the host, and we'll do the mapping. If you remember Docker run command, you give -p and say map my 8080 on the host to 80 of container, something like this. Remember? Yeah, something similar we are going to be doing here. I'm going to expose this deployments. As soon as that is done, I can see that I have a service running here. Kubernetes service was running there by default. This one is actually running right now, and this is the IP within the cluster, right? But then from outside, again, remember, this is my local machine, a single node cluster. There is no load balancer here. There is no cloud load balancer. There is no cloud right now. So I have this port which is exposed now and mapped on the host 31190 to container port of 80, or pod port of 80 in this case. So I just go and say this, and you can see a very stupid Docker image running there. Now you will see, just pay attention on this one. You see this number is changing. So sometimes it's SXSVP, sometimes it's JNSJJ, and these are the 2 containers. So what's happening here? I'm going to a port on a service which is actually doing load balancing for me across these 2 pods. These are the host names of that pod. The image that you see here actually grabs the host name from the container and then puts it there below the logo, just for easier understanding of load balancing there. It's a pretty unique and nice and easy case of very simple load balancing. You are trying to reach to a single service on this port. Ultimately, internally, it's sending requests in a round robin fashion, mostly to this individual pods that you have, JNS and SSF, whatever it is. Pretty simple, right? Pretty easy. That's what I had for local setup. Nothing you did actually for setting up. Instead of just you ticked a box in this preferences, and that's it, because Docker took care of all the stuff. So if you have any question, post it there. I will answer it later down the line. But let's move on to install it onto AWS. So we'll need a lot of stuff to do. I'm gonna just disable it for the time being, let it stop. So the first thing I have to decide, okay, what should I name it? First of all, you need an AWS account. So let me log in into my labs account, which I'm already logged in. So the first thing you need is a domain, right? You want to install a Kubernetes cluster. I have bought this domain and configured it. Don't worry why it's subdomain and not the domain and all those kind of pieces. So I have this domain, kitis.inet.academy, and that's it. Nothing there, just the name, server record, and a SOA record, nothing more than that. And that's actually the name I want for my cluster as well, because remember, Kops uses DNS for the cluster discovery, right? So that's why these are same. The other thing is Kops needs to store configuration, live configuration of the server somewhere. You can put it on your machine, but the preferred practice is to put it onto an S3 bucket on AWS and make sure you only have, or at least the admin group in your DevOps team has access to this S3 bucket and not anyone else. So don't make it public. You can create it from command line, or you can create it from S3 UI as well if you want. Before doing that, you need a user as well. I'm just going a little detail into AWS CLI. If you don't know, just go and understand how you can use AWS CLI from your command line, authenticate to AWS account and all that. So pretty fast, I'm just gonna go into my IAM credentials and create a brand new user. I'm just gonna give it a programmatic access, nothing more than that. I don't need UI access for this guy. What you need is actually a role which has few details, because you are letting CLI or Kops behind the scene do stuff on behalf of you. So you need to provide some permissions. So I'm just gonna go and show you all the docs that you ever need to do and play with Kops. So I'm gonna go here. And then these are 4 different privileges, or 5 actually, that you need to provide to your user. So in this case, I'm just gonna go there and I'm saying, you know what, attach existing policies. I will copy one by one. Check. You can alternatively create a group and assign it as well. That's the preferred practice, but I'm just avoiding a couple of more screens. I'll just describe what these things are actually, why you need all this access. Because again, remember, Kops is going to set up a lot of things behind the scenes on behalf of you. So if you see, you need full access to EC2, you need Route 53 access as well, because again, Kops will manage all these things for you, will set up a lot of stuff, it will create a new bucket, will write into the bucket, it needs access because it will create a lot of roles, set up authentication, all these pieces for you, and then of course, it needs full access to VPC, because it will create a lot of components on your VPC side. So let me just configure my local AWS. I'm just gonna say AWS configure. I have the keys, so let's copy the key. Never make anything public, especially the secret key. Default region name, I want to make sure I am using US East 1, and then I want to have JSON output from AWS CLI. That's it. So what we did so far is we set up our AWS CLI locally, so that from terminal we can talk to our AWS cluster or AWS account for that matter. So let me verify it works. Yep, it does work. I can get who I am. Now the first thing that Kops need from this user is create this bucket. I'm naming the bucket with the same name as my cluster and calling it state store. I'm gonna create it in the US East Northern Virginia. Do that. If you go and check your S3, yeah, it's created there. A few things you can change. You can enable versioning of it. I would prefer creating a version every time something changes, because remember, this is where Kops will store all of your Kubernetes clusters configuration, and then over time you may want to upgrade, you may want to scale up or down on your own, not just the auto scaling and a lot of stuff. So you can enable versioning. You can actually enable encryption as well, the default one. At least those 2 things I would prefer, and make sure no one else has access to this bucket apart from very core people in your DevOps admin team. So once that is there, we already put the versioning from the UI, don't need it. The next thing is we need to create this environment variable called Kops state store. In the commands following to this, it will need to know where is your S3 bucket, right? This is the name of the S3 bucket that we just created, this guy. So I'm just gonna execute this command to have this variable set up in this particular session of the terminal. And once that is there, you will not touch AWS CLI now. Next thing is, okay, let's go and run this command called Kops create cluster. Tell what zone to create some of the nodes. what is the name of the cluster. And if you do this, what Kops will do, it will go and create the configuration required for it. It's the simplest command that you can use. Instead of creating and applying it to the AWS account, I'm just saying, you know what, don't apply it. Let's just look into what you are gonna be applying, what all things you're gonna be creating. And that's where I'm using dry run flag and saying, you know what, output it to the YAML configuration. So once that is done, let's see what's the default configuration that Kops will have. Minimalistic create cluster command. Let's see what configuration it's trying to put. Where is the output starting? Okay, so it looks like a YAML file with a type of cluster. The name is of what we said. Then it has the API DNS configuration there. Enable RBAC. This is for the security. Whenever you want to talk to API server, you need to present authorized certificates. So that's where RBAC is by default enabled for you. There are stable and an edge channel. Edge is where all nightly builds are going, so we want to use a stable one. Of course, our cloud provider is AWS. Remember, in case of Kubernetes, when we started, we talked about this guy, CCM. How would Kubernetes know, or how would Kops know what to install, whether AWS specific CCM or Azure specific or Google Cloud? So that's where we are saying, you know what, deploy CCM specific to AWS. Where is your configuration? Then where should I create my etcd cluster? In this case, there are two etcd servers or storages that it will create. Then with the IAM, AWS has something called Elastic Container Registry. It's like a private Docker registry for your AWS account. By default, it's enabled if you want to use it. From where do you want to access Kubernetes API? I'm saying, yeah, make it public, keep it open. Everyone can reach it from outside the VPC as well, so that's why it is. Now I want to install Kubernetes version 1.10. Specifically, what is the domain of API server? API dot your cluster name. What should be the VPC CIDR? Remember, Kops is taking all these decisions on its own. We don't have to worry about all these pieces. What networking are you going to be using? So we are saying, well, by default, it's going to be using KubeNet, which has a limitation from AWS. In a routing table in AWS, you can only have 50 routes. So that's a limitation. Now for pods, what should be the IP addresses range that you want to use? Kops has already took that decision. This is private IP address range anyways. It's a very huge range if you see /10. Whether you want to be having an SSH access, if you want to have SSH access to this cluster, from where you should be able to do it. I'm saying, yeah, from all over the world, you should be allowing it. Of course, in an ideal hardened cluster, all those things will be limited to your VPN or your private network. It will create subnets. In this case, in one US East 1A, it will make all the nodes, whether those are type of worker as well as master, in the public subnets, not something that you would want. So DNS means all the load balancer will be in the public, and then the masters and nodes will also be in the public. Then it has a couple of more configuration, one for the master. Then here, one node which is of very small capability, T2 medium, two nodes actually, max size and min size. So that's pretty much the default configuration, and I'm like, I don't like it. I want to change few things there. I want to make some customizations, right? That's the whole point of using Kops. Otherwise, we could have gone easily with EKS. We can just do 4 farm entries inputs in EKS farm, and then it will deploy. You won't even know what's running under the hood in EKS, but at least in Kops, you have that customization ability that you should be able to do. So let's go into the next one, which is a little complex. Here I'm saying, okay, this is my DNS, fine, this is my zone. I want to use M5 large type of EC2 instance. I want one of it. I want 2 nodes of M5 large as well. So I am controlling it now. For the networking, I'm going to be using KubeRouter. Pretty powerful routing plugin coming from Cloud Native Labs, I think. But then make sure my masters and nodes are in the private subnets. They are not exposed to the outside world, right? Pretty good. Also, since these are in the private VPC, I want to have a bastion or jump box in order to reach to my VPC, right? In order to SSH, and then the name as it is. So what I'm going to do, I'm going to run this and then understand, okay, what type of configuration it gives me. Again, in this case as well, this was a single master, not highly available, right? This is a single master. So here, what you see is you have same stuff. Load balancer will be in the public, fine, RBAC, same stuff, same thing here as well, nothing changes. Same CIDR for the VPC. Same CIDR for the pods and services. So in this case, I said, you know what, I need to have my master nodes and the worker nodes in the private subnet, so it has created a private subnet. But for the bastion and the public load balancers, it will create a utility which is a public subnet as well. It will figure out, okay, your bastion name or the DNS will be this. It will internally create a Route 53 entry as well, and then you can see the difference here. Your masters and nodes are in the private, while your load balancers and DNS are in the public, right? You can change those pieces as well. Again, same thing, instance group. You have one master, two nodes, and this time one bastion as well, which is just the jump box, nothing more than that. And you're like, fine, pretty good. One thing here, in this case, still the API server is exposed to the world. You may not want it. In a production ready hardened cluster, you would want to block it, or you want to allow access to the API server only from within your VPN or your private network of your office. The third configuration that I want to see is, you know what, one master doesn't work for me. I want to have multi-master, and I want to make sure one master in one availability zone, and I want 3 availability zones, each having one master. I want 2 nodes, worker nodes in each availability zone. So I want my entire cluster very highly available. This is actually the configuration that we started here at Init, and then we scaled up number of nodes and different types of complexities here. But this is how a simple but very powerful, highly available cluster that you can create on Kubernetes. Remember, so far there is nothing created on EC2 or VPC. We are just looking at the output of those commands, not running. They are not run yet anywhere on your AWS account. There's a different command to run it. So in this case, let's see. I said, you know what, I want 3 zones to be targeting, 1A, 1B, and 1C in US East 1 region. I want 3 masters of the type M5 large. I want 6 nodes of the type M5 large. I want to use same setup as before. And this time what I'm going to do is I'm going to just output all this to a YAML file, which I can commit it to my Git repository as well, right? So let's go into this folder and cat on this. You know what, I should open it into Sublime Text. So what do I have here? Same stuff, nothing changes. Load balancer is public, fine. This is my store. Things have changed here. Now you will have 3 etcd cluster in each availability zone, 1A, 1B, 1C. If one goes down, two other will be available there, right? And then one will come back again. Kubernetes API access is still public. You can make it private as well and limit it to from a certain CIDR. Networking is fine, all good. Now you see how many subnets have been created here. 1A, 1B, 1C. These are 3 private subnets which have been created to host your master nodes, and your worker nodes will be created whenever you run it. Then you have 3 utility subnets, which are public facing subnets for your load balancer, for your bastion. Bastion name is this, the rest of the stuff same. Now you will have more instance groups, configuration for your instances, right? One master in 1 East or East 1A with this particular image. 1B will have 1 master, 1C will have 1 master, and then you will have 6 nodes across 3 different availability zones. These are worker nodes. It will distribute 2 in each, and then you have 1 bastion here. So that's actually exact cluster YAML that we started here at Init almost 10 months ago. Then a lot of configuration we have changed over time, but this is how you start here. Now once you have it, you can just go and say, instead of creating from this complex command that we used before, if you have it in a YAML file, you can just use create f flag and then just say cluster.yaml. That's the whole concept behind infrastructure as code, right? It's configuration that you are saving with your version control. One thing that I want to change here is, since I'm using M5 large instance, there is a change in the networking, the way it used to work in M4 large, an old generation of the same capacity EC2 node, versus this M5 large. This particular image doesn't work. There's a new version for that particular type of load that I'm changing here. So I'm gonna change it to master. This one is gonna understand the new configuration of networking on M5 type of, which only came this year actually. So there was a change in the AMI for it. I'm just going to replace all over. It's a new version of Debian actually. So once you commit and your configuration, you have access to a lot of good stuff here. Cool. So once that is done, all the configuration is there. The only thing that you have to do is go and hit this command and just grab a cup of coffee. Yeah, so it has validated that all the things are good in this case. So of course it found out you have a cluster, 3 different instance groups for the master, 1 instance group for the 6 nodes, and then 1 for the bastion as well. And then now it's saying, you know what, in order to deploy it, just run this command. So we'll be like, oh, sure. Now it will complain, asking, I need your SSH keys as well. Remember, we are setting up EC2 nodes. So from this machine, if you want to talk to those or SSH into those boxes, your public key has to be copied from here to those EC2 machines, right? So it's saying, well, create a secret if your key is available at this place, your SSH keys. If those are not, generate them. As soon as I create this secret, Kops will use that public key now, and then if you run update cluster next time, it will use that public key that you have on your machine and copy them to all the our EC2 instances that it's gonna create. And you can see it's doing all those things automatically. It's first of all issuing all the certificates. Remember, one of the things that you needed in Kubernetes setup is generate all those certificates, right? That's what it's doing. Then it's creating the instance profile, which is an auto scaling group, target group. Then it's creating the network gateway. You can start refreshing on here. Yep, you can see these things are coming up on your VPC. You have a brand new VPC now. You have subnets created as well, all of them. You have routing table created and getting configured for private subnets and a public one as well. You have internet gateway was created for you, elastic IP was scheduled for you, and the NAT gateway will be created. If you go back to EC2, you will have volumes getting created for your etcd volumes, remember, right? Or all the masters, all those pieces and the nodes. You will have proper security groups getting created for you. And again, I did not create anything, maybe except this one. Load balancers are getting created for you behind the scene, right? So it will take a few minutes. This is the first time it's booting up entire cluster. The nodes are up and running, so it will take some time. Looks like this is still creating the network gateways for those private subnets. And by the time it creates, let's just understand what it's doing behind the scene. So this is what will happen. You will have 3 masters which are already up and running in different AZs. Then in each AZ you will have 2 nodes, N2 and 3. So sorry, N1 and 2. These are 2 more nodes because we said 6 nodes, worker nodes. And then they will of course all be in VPC in your AWS. Then what you will do, because you want to access API server which is running on all 3 of the masters. Remember, these are all in 3 different AZs, okay? This is 1A, 1B, 1C. It's a highly available cluster that you would want. So it will set up load balancer, ELB in this case because it's AWS, which will talk to all 3 master nodes. Then it will create a bastion on the boundary as well in the public subnet so that you can actually SSH to your bastion first, and from there you can go to the internal of VPC and go to all of the nodes from there. This is where you will be reaching out to the API server. So this is what it's gonna be creating behind the scene. And it says, well, cluster is starting, it should be ready in a few minutes. There's a command to validate the cluster, and it will take some time because the API load balancer may not be up by this time. So bastion is ready. API server, it's still booting it up. It takes some time around it. Let's go and check Route 53 as well, because some entries have already been created by Kops for you. You see, there were only 2 before. Now you have all these entries about where are your etcd cluster, how you can reach to the API from outside or inside. the cluster and how do you reach Bastion as well. You can actually go to the Bastion server easily, which is not a server, it's just a EC2 instance. A lot of this stuff, I don't have time to go for all of this today, but yeah, you can actually validate the cluster. That's what we are trying to do. But then if a cluster is already running, and then you may want to change maybe type of your master in a running cluster. You may want to change from M5 large to M5X large, although you may never need it. But maybe for the nodes, you want to increase from 6 to 9, right? Give one more node per AZ because you have 3 AZ fashion here. So you can do that by just going and finding this command, which will open the same exact file like this in your editor. And then you can say, go and say, you know what, now I need 9 EC2 instances or something like it. You can scale it very easily by using commands like this. And then you can do a rolling update on the cluster. Again, the whole idea here is it's an immutable infrastructure, meaning the old nodes will be removed from the cluster, new one will be provisioned and added to the cluster. So that's how it's going to be. By the time it starts, so it's at least API server is now responding. Yep, all 3 masters are available, or you can reach out. There are a few still nodes which have not yet joined to the cluster, so they are in the process of joining. But all the masters are already there. Maybe these nodes are lazy or having some time. Okay, cool. Then some, it's not really some pod, internal pod for the kube system. Kube router is not healthy there, so it's gonna take some time. So that's it. That's how you actually set up your Kubernetes cluster using Kops. Pretty easy to do it if you understand, but most important thing here is the customization that it allows you. We'll modify this file again next time when we add IAM support or a lot of other stuff, including versioning and maybe editing a cluster live when it's running live, running your workload in production. You can edit your cluster. The other option was EKS. That's pretty easy. It takes a lot of time. So what I did actually, I created a cluster before coming onto this one. I can just go to the create screen and tell you how easy it is from there as well. You name the cluster, you pick the version, whatever the version EKS has at that point. You don't have many options there. On Kops side, you have a lot of options of choosing what version of Kubernetes you want to run, whether it's the latest or the oldest supported or whatever. One thing that you did not worry about in Kops was actually it created a lot of roles on your behalf. So if we go there in the roles, it has created a Bastion role, a master role, a nodes role, a lot of stuff. For EKS, you have to create at least one. Having EKS service I created, you have to create your VPC before, and of course this is the Kops one created. You have to create one, you have to say which subnets you want to create and which security groups you want to edit and what roles and what rules should be there and all those pieces. And once you finalize, you hit create. A few minutes, maybe half an hour later, you will have a cluster running there. There are pros and cons. Well, I would say differences between the way Kops creates a cluster versus EKS. But that's how you can create via EKS as well. But let's understand what's the difference. How Kops is handling or creating your cluster versus EKS in this case. So one of the major issue with all the users who wanted to use Kubernetes on AWS was Amazon or AWS took hell lot of time to make EKS generally available. It was made available only earlier this year, while Kops has been there, and many companies are using Kops now for almost 2.5 years, or more than that, maybe at least 2.5 years, using Kops to run Kubernetes cluster on AWS. So it's very famous already. EKS has just started. Now, another thing with EKS is it's only for the Kubernetes masters. You still have to create and manage an auto scaling group and everything for your own worker nodes. EKS does not care or does not configure or does not provision your worker nodes. It only cares about the master. Of course, it's going to make sure your masters are highly available. It will run it in multi-AZ setup and all that. Then again, you still need to do a lot of setup for the worker side of it, right? Another problem, you don't have any control on the master. What version of Kubernetes you are running there? Yeah, forget about it. It's only EKS that will manage it. Now, one good thing I found out, which you can do with Kops as well now, is with EKS, It has a seamless authentication of kubectl to the API server, and it uses IAM behind the scene. Very easy to create a new user or admin for your Kubernetes cluster and shut the access down when he leaves. With Kops now, we internally use this plugin called AWS IAM Authenticator, which is actually internally used by EKs as well. EK support networking concept called ENI, which is CNI, Container Networking Interface by default. There are limitations in terms of how many pods you can run on an EKS worker node. That is determined depending on how large is your EC2 instance. So there is a limit there as well. That's why you may not want to use very large number of instance types there. Depends. So there is a limit actually how many pods you can run, and that becomes stupid limit when you only want to run UI pods, right? Maybe all Nginx, not using more than 10 MB of RAM. EKS, of course, integrates very well with CloudWatch and CloudTrail, so that's a benefit that you get. One thing with Kops is, of course, you can pick whatever version is supported there. There are a bunch of version. 1.12 is the latest right now, and then there are a lot of options available in this freaking spec. We'll go through over the next 6 weeks, understand this pieces, which is this file, and there are many more options available. Forget about finding those options to customize your cluster in EKS because that's totally controlled via managed service. Kops outputs all the configuration to Terraform optionally. That means you can run the same configuration on other cloud providers, including Google, Azure, whatever your next target. The whole thing I liked about Kops is it keeps Kubernetes in Kubernetes. What you get is raw Kubernetes installed, no other modifications, right? No other hidden things with it. It gives you raw Kubernetes as it is. What do you have? Few important things. I think if the cluster is up, I just want to run get nodes command. Some machine has not joined, so get nodes. And you can see, I can see all the nodes which are running here. 3 master, 5 nodes, 1 node is still trying to join the cluster, which will come. If you go there, all these machines are running. Nice and easy. Your auto scaling configuration is already up, meaning if a node goes down, Kops has set up ASG for you, so AWS will bring those nodes up and then keep them with whatever your desired state is, right? That means nodes, masters, anything, if it goes down, it will come back up in the same configuration, in the same AZ. Kops has already set it up, your entire cluster in that fashion, and AWS will honor that setup now. The only problem I found, which you should be keeping in mind, is if the node goes down, it will come back up. But if you want to provision an auto scaling policy, like if 80% of the CPU of my cluster is used, add 1 more node. So that's scaling policy. That is not created by Kops for you, that you have to create. Another thing that you will realize down the line, you need more than 2 nodes per AZ in a highly available cluster, because there is a trick with AWS volumes. You cannot transfer your volumes across AZ. So let's say if your database is running in 1A and then the node goes down and Kubernetes tries to bring that pod again on 1B, good luck. It won't be coming up because the volume wattage is still sitting in 1A AZ. So that's going to be the case. We already looked into it for the new M5 instances. Make sure you are using the newer version of Debian. Kops rolling update works nicely. We have tried it out at least a couple of times while production being there. It goes one by one with all the nodes, remove 1 node, add 1 new node with new configuration, and then do it for every other node, whatever you are asking. There is one link that I have mentioned here which says what Kubernetes is not. Interesting read if you want to go through that as well. It's not a pass, right, like OpenShift or EKS or all this kind of stuff. It's just trying to provide you a platform, but not as a platform as a service. Just a simple container orchestration platform there. A lot of good stuff there as well. And let's see if I have all the nodes ready. Yep, everything is ready. The cluster is up and ready. And if I do nodes, all the stuff is available. One last thing is, how am I able to access the cluster? I didn't do any authentication or anything, right? Well, that's because when Kops installed on your machine, it gave you this configuration. It created this file, kubeconfig, And the kube config has all that information about your cluster. If you have multiple cluster, for example, I was using a Docker for desktop local cluster, so that cluster is also there. But then this is my AWS cluster, and it has CA authority data here, which is actually what you get from EKS as well, if it's still there, this guy. So this is like a TLS certificate for your server, so that you know that you are talking to a real valid server. Then you have some context, we will talk about it next time. You have your user. In this case, this is the user I'm talking about, the admin user with this password, and there are some certificates and the private keys created for it. But again, when we go and use IAM, we don't need this, because right now in this fashion I cannot share my kube config to anyone else. This is like my password to talk to my Kubernetes cluster. I do not want to share even with other admin in the same DevOps team. And that's where IAM, how you integrate all of your Kubernetes configuration, authentication with IAM, that's what we'll talk about next time. So that's all for today. And before we go and round this up, let's make sure we delete the cluster, because it's gonna consume a lot of resources on AWS, right? So simple and easy command, delete cluster. What was the name of our cluster? And then I'm just gonna say forcefully yes, delete it. What it's gonna do, whatever it has created so far, whether it's configuration inside it, all this, or all this your auto scaling groups, or your load balancers, or your EC2 instances, or everything in your Route 53 entry which it had created, not the ones that you created, or your net gateways, your VPCs, your subnets, your routing tables, security groups, NACL, it will just go and delete every damn thing that it created for you. It will bring back the same setup that it was there an hour and 15 minutes ago. So let's delete, and that's wrap for today's collective. Anyways, so that's it for today. Next time when we come, as I said, we will configure and harden our highly available cluster. We will make sure that this kind of configuration are not shared, and even if they are shared, there is no harm to the cluster. We'll make sure, and we'll do it by using RBAC and then plugging AWS IAM for authentication with your cluster. So that's what we'll do next time. Thanks, guys.